In this second example for calculating average acceleration, I'm going to take a look at two different sets of data that are different than the first example. So I have two sets here. The first set is a downward sloping line where my velocity is decreasing. So my velocity is going down here to these data points. And the second example is are the x's here, where the velocity data is constant as time goes by. And what I'm going to do here is find the average acceleration for each of these examples. I'll call this example 1 here, and I'll call this example number 2 here. Okay. And as we saw from the previous example, the average acceleration is, I'll do the first one here. This is average acceleration, is the delta v over the delta t. So for the first example here, I'm going to choose two data points. I'll choose, let's say, this guy here, and let's choose that one there. Okay. So my average average acceleration is the final minus initial. So my v final minus v initial over time final minus time initial. So I'm going to get, let's see, my final velocity is going to be 10, because I'm going to take, as time goes by, time is going this way. So my final velocity here is 10, and my initial velocity is 14 at the top there. My final time is 3, and my initial time is 1. So this is going to be negative 4 over 2, which is negative 2 meters per second squared, which is consistent with the fact that it's slowing down. It's decelerating. So this is a negative quantity. So that's what the negative stands for. The square should be a little bit lower down here. So hence the negative sign for a decelerating object. For the second object, object number 2, I use the same equation. The average acceleration is equal to change in velocity over change in time. And here you can see that there's no change in velocity. It's 4 minus 4. It's 4 the entire time over, I use the same time frame, 3 and 1. So I get 0 meters per second squared, which means that there's no acceleration rate, or it's going at constant velocity. So I'm using the same equation, and I'm taking a look at two different examples, one for an object that's decelerating and one for that's traveling at a constant velocity. Key point here is a negative acceleration rate means it's slowing down, and 0 means that there's no acceleration or it's moving constant velocity.